Hello everyone, today I will show you the DC analysis and then the AC analysis of BJT common emitter amplifier. Why we call it common emitter, by the way, because we apply input at the base side and take the output at the collector side, so emitter will be common emitter amplifier. So my circuit is like this. Here's my input. Here's my source resistance. These R1 and R2 are for DC biasing the circuits. Here's my transistor, and then here there is again capacitor. These capacitors are for blocking DC and passing AC. So what do we mean by blocking DC? Also there is a capacitor here. Sorry. Also there is a capacitor here. Okay. These capacitors will not pass DC signal. I mean, capacitors are, for DC analysis, capacitors are open circuited. I mean, there will be open circuit means there is no current passing through. Current equals 0. There will be no current passing through this side, and there will be no current passing through this side at DC analysis. So, at the very basics, a BJT is a transistor. Here this is NPN type BJT collector at the higher potential for amplifying purpose. Be careful, for amplifying purpose we use BJT in active modes. What do we mean by active mode? V collector greater than V base and V base greater than V emitter for NPN type. So here there is base, here there is emitter, here there is collector current comes in, here base current comes in, and emitter current comes out. There is a basic current relationship between BJT currents, collector current equals beta times IB, and also if we write here KCL, emitter current equals base current plus collector current, because emitter current comes out the transistor, base and collector current comes into the transistor. So also there is a voltage drop because of PN junction. There is a forward voltage drop here between VBE, and generally it is given in the question, and it is like 0.6 or 0.7, and majority carriers for NPN type BJT, majority carriers for NPN type BJT is electrons. Remember this. Okay. For PNP, this time, this is the symbol of PNP. This time emitter at higher potential and then base and then collector. There is still a voltage drop between emitter and base, but the order is reversed. Emitter at the higher potential. This time VEB equals 0.6 volts, or generally they will show it like this: VBE absolute value equals 0.6 volt. Here emitter current comes in, base current comes out, and collector current comes out. The current relationships are the same. I mean, still collector current equals beta times IB, and still emitter current equals IB plus IC. So what is change? Majority carriers change. Majority carriers for PNP type. This is PNP type BGT. Majority carriers for PNP type BGT is holes. Okay. Now you have all the knowledge to analysis DC, to make DC analysis of this circuit. So if we replace capacitors as open circuit for DC case, my circuit becomes like this. Here there is VCC, here there is R1, here there is R2, RC. So in DC case, my circuit becomes like this. Right now, I will simplify the circuits. How can we simplify these circuits? Simply just doing, look at this side. I mean, I will look at this side and write VThevenin and RThevenin equivalent. How can I write VThevenin? VThevenin equivalent equals its open circuit equivalent, and here if you look at the circuit, if you open circuited it, you will see a voltage divider circuit, R2 over R1 plus R2 times VCC. It's my VThevenin. So what is RThevenin? How do we find RThevenin? Remember, when you find an equivalent resistance, you shut down the active sources. What do I mean by this? If there is a voltage, independent voltage source, you make it short-circuited. If you have an independent current source, you make it open-circuited. So here, when you find RThevenin and look at this side and find RThevenin, you will see there is a voltage source here. You will make it ground, short-circuited. So my circuit becomes like this, R1 and then R2. Then you connect a test voltage, V test, and there is a current I test. And if you find V test over I test, this is my RThevenin. And here in this circuit, it is equals R1 parallel R2. Why? Because I test have two paths to go ground. One is R1, one is R2. So now I will replace my circuit with VThevenin, my left side of circuit with VThevenin and RThevenin. It will be like this. Here VThevenin, here RThevenin, and then here are emitter, here RC. So now it is easy. There is a voltage drop between base and emitter voltages. There is 0.6 volt. Right now I will write KVL here. VThevenin minus RThevenin times IB minus 0.6 minus beta plus 1 times IB times RE equals 0. If I rearrange this, VThevenin minus 0.6 divided by VThevenin minus 0.6 divided by RThevenin plus beta plus 1 times RE equals base current. Here I know VThevenin, here I know RThevenin, here I know RE, and here I know beta, so I can solve for IB. and then I can find collector current simply by this equation. And if I add collector current and base current, I will find the emitter current, and I am done. This is the DC analysis of the BJT common emitter amplifier. So I will make another video for AC analysis of this circuit. See you at the next video. Bye guys.